Welcome to 1.4. If I were to be asked what my one most important general concept that you would get out of this course for the first semester is, that would be an easy one for me. I would say that I would want you to be able to look at a number of different functions. For instance, let's say we have a function g of x equals x squared minus 2x plus 3. I would want you to be able to look at that and very quickly in your head or on paper be able to sketch out or see what the graph of that function looks like. The answer to most questions in algebra lies in the graph. So with that said, 1.4, there's no section in the book that does more to help in that fashion than 1.4. So needless to say, in my opinion, this is the most important section of the first semester. This is one that's going to keep coming back and coming back. And there are a lot of things in mathematics that we can get by memorizing. You know, I learned this new process. I don't really get it, but I can do it. And sometimes that's satisfactory. It's not ideal, but sometimes it's satisfactory. But this is most definitely one you're going to one that you're going to want to understand. So I'm going to take my time on this and make certain that we end up understanding. We want to know why graphs shift, why they get bigger and smaller, what causes that. You can see the danger in memorizing this as we go through some of these things, and this one as well. It's like, oh, well, shoot, even functions, odd functions, reflections in x-axis, reflections in y-axis. The rules in a lot of these things in mathematics are very, very similar. It's just a matter of moving a negative sign. So understanding these things becomes critical down the road for you. So what do functions do? Let's say we have a function f of x and typically in algebra it's f of x, but it could be f of t or g of t. Oftentimes it's time. So what happens in these factories or functions is we put in an x value algebraically and we get out a y value. So these are factories that turn x's into y's. And our factory might take any value. Many functions you can put anything in there you want. Some functions you can only put in a small select number of values. But let's say for our purposes we've got a factory that we might be able to put in any number we want, but let's say that all we've done so far, I put a 3 into this factory, and we'll use f for this one. I guess I could use h, but we'll use f for this one. I put a 3 into it, I went around back, and out back they took that 3 and somehow or another they turned it into a 5. So 3, 5 becomes a point on our graph. And I'm saying this graph has a whole bunch of other points on it as well, but all we know right now is that f is a factory that turns 3's into 5's. I'll repeat that. F is a factory that turns 3's into 5's. So f of 3 equals 5. So let's consider this vertical shift idea. What if I wanted to deal with f of x plus, let's say, 4? Well, I don't know what all f of x is, but I do know what f of 3 is. So I'm going to replace that with f of 3 plus 4. And f of 3, f is a factory that takes 3's, turns them into 5's. So our point that was at 1, 2, 3, 1, 2, 3, 4, 5, that's the only thing we know happens on our factory, now gets moved to put in 3, get out 9. So we notice that's up 1, 2, 3, 4. Well, this should hopefully make a lot of sense to you. I'm really looking at this as a post function right here, where I'm going to take a value x, I'm going to put it into f, and then I'm going to turn around and I'm going to put that into another factory that just adds 4. I call this a post function. And post functions are adding to the height. In other words, x is a right-left value. Once we come out of the factory, so we go right 3, once we come out of the factory, we're now dealing with an up. This is an up-down value here, this 5. That's a y value. So I put in a right-left, I get out a height. I get out the height of the function, and then I add 4. I'm adding 4 to the height. Oh, I add 4 to the height. Well, that makes sense. Post function, I'm adding after the function does its thing. And post functions are generally pretty easy to understand. So what about f of x minus 2? That's f of 3, the only function we know what's going on, minus 2. The height, when I put 3 in, our function turns 3 to the right 3 into up 5. And we get 3 down 2. Oh, that's pretty simple to understand. I put in a right-left, I get an up-down, I get a height. So I'm subtracting from the height. But now we have a pre-function, and these ones are a little bit sneaky. So let's consider f of x minus 4. Now, the only thing I know about this factory is that it turns 3's into 5's. It turns 3's into 5's. So the only thing that I know for sure I can put in this factory is a 3, so I really need x minus 4 to equal 3. And therefore, x needs to be 7, so I really need to find f of 7 minus 4. It's the only thing I know for sure that my factory does. Oh, that's f of 3, and f is a factory that turns 3's into 5's. Therefore, I put in 7, and eventually I got out 5, which is 1, 2, 3, 4 to the right of there. And the common mistake is, oh, well, it's minus, and if it affects the right-left, it must shift it to the left. But our MyVox, our most interesting value of x in this case, would be when x is 7. That is 4 to the right of the value we want to put in. You might want to think of this as, let's say that this is days and inches, and I'm just measuring corn. So this means day 3, my corn's 5 inches tall. Well, this is affecting the days, the x value. You might want to think of this as a 4-day delay. It slows the process down 4 days. So what normally would happen on day 10 now does not happen until day 14. Shift to the right. What normally happened on day 3, we find out happens on day 7. So there you have it. Likewise, you might want to think of this. Let's think of f of x plus 2, for instance. Well, we need x plus 2 for our purposes to be 3. So x plus 2 is 3, x is 1, so f of 1 plus 2 is f of 3 is 5, x is 1, y is 5, that is 2 to the left of our known point. Think of this one as a 2-day head start. We planted our corn 2 days sooner. So what normally happened on day 3, now if it has a 2-day head start, happens back on day 1. Or what's our MyVox? Our MyVox is the value that makes this 0, gets us back to our starting point. What would x have to be for this to be 0? X would have to be negative 2. Shift to the left 2. Now, if that did not make total sense to you, highly recommend go back through that, pause it, get your head around this one. I will not stress any other section more than I stress this one. This is not a section you can afford to be pretty good at. Pretty good at this means that every section, pretty much every function we study this semester, you start at pretty good and go down. We want to just nail this section. Okay. If that does make sense to you now, then I think these are going to be pretty easy for us to understand. So this is this example 1, this negative f of x could be represented as negative 1 times f of x. Now let's review. What do functions do? We put in x, a right or left value. We get out y, a height value. Or we put in days and we get out inches. In this case, we put in a left-right, f turns it into a y, f turns it into a height, and then we multiply the height by negative 1. Oh, we're multiplying the height by negative 1. So if f of x is 5, then negative 1 times f of x is negative 1 times 5. Oh, it just makes the graph, what used to be up 5 now becomes down 5. This makes the graph upside down. Example 2, however, this negative 1 is a pre-function, f of negative 1 times x. What's happening here? I choose x. In here we're multiplying it by negative 1. And we get out negative x. We haven't. That's where we start first. And then we take that negative x and we put it into f. Okay, so the height isn't changed here. What's changed is the x value that we started with becomes opposite. We want opposite, sorry about that. We want opposite right left. What used to be right is now to the left. If I have a point here, then I must have a point back here, equal distance, equal height. Equal distance to the left, equal height. So we get our h of x, the reflection of is a reflection on the y-axis. This is a reflection on the y-axis. But rather than memorize that, oh, it's a reflection of the x-axis, reflection of the y-axis, I would rather say, hey, time is going backwards. What was 3 days to the right is now 3 days to the left. This graph is backwards. So I know I took my time on that. 12 and a half minutes of your life right there. Probably worth reviewing again unless you feel like you are 100% on board with this. Trust me, you will get practice.